What we're going to be covering today is the SolidWorks Weldment package. And what that entails is the ability to make structural members inside of SolidWorks very easily, generating a cut list and showing you how exactly to trim up all the pieces together. If we take a look at this assembly that I'm showing on my screen, this is that hydroplane that we created in the surfacing class. But if you take a look at what's underlying this assembly, I've got a few weldments right here. One is this roll cage for the forklift. Another one is the frame body of the hydroplane itself. And then we're spitballing ideas on how to get this thing out of the water if it needs maintenance or needs to be moved. So for this, we're going to build a boat trailer again. But before I do, let me talk a little bit more about conceptual design as far as when is a good time to create an assembly and when is a good time to create a weldment. Hello. I did just get started, so haven't gone too far. What we're going to be covering today is, if you take a look at this assembly, there's weldments inside of it, which are basically structural members that have been trimmed up to each other. So we're going to build some of these skeletons that are underlying our design here using the weldment package inside SolidWorks. I'm going to open a couple of drawings here. This one's an assembly drawing. I also want to take a look at the weldment drawing as well. So put one on either side here and take a look at both of them. And you see they look very similar, where we've got balloons calling out items, we've got lists for them inside of the assembly. Each balloon is calling out an individual part file, and the list in question is called a bill of materials. Inside the weldment, it's calling out member bodies inside of the weldment. The weldment is actually in a single part file. And the real magic is where it's actually showing us what lengths of tube and whatever types of cross-sectional members you're going to use are inside of that weld. At the assembly level, you can actually roll up stuff that you want. You see, in this assembly, you can actually see that weldment that I was just looking at. There's several weldments in here. If you set your bill of materials to look at an indented type of list, you'll see that it actually gives me a total amount of pipe that I need to create that part. So at the part level, it's showing the individual member lengths. And then when you look at it at the assembly level, it's going to show you an overall, this is how much of this particular structural member you're going to need. So this is the assembly. And the main thing that assemblies have going for them that weldments don't is you can actually do like a proof of concept, where I can take a look at dynamic motion. When you're looking at a weldment, you're going to be in a single multi-body part file, but everything's going to be static, which you would expect because it's all welded together typically. When I take a look at the weldment itself, it's got a cut list inside of it, and that gets generated automatically. You'll see that as I go through this example, how we can build that. It can have sheet metal parts in it as well, which you can take a look at the flat for the individual sheet metal components inside of the weldment. But again, it's a static design where the assembly had the ability to move. Okay, back in the assembly. How this assembly started was actually with a 2D sketch. So this isn't really about weldments. This next little section is just about conceptual design. You can do design for range of motion. You don't actually have to build an assembly and mate everything together just to get an idea of where things are laid out. How this assembly started was just this part right here with a sketch inside it. But you'll see that you can actually get dynamic motion inside of a 2D sketch. How you do that, you have to be in the sketch mode. And you see all this stuff with dimensions on it, that is just sketch geometry. The rest of the stuff have been put together in blocks. And blocks can be mated together using sketch relations. So you can prove out, things we've got in range of motion. Let me show you how I did that. Notice as I'm drawing here, I'm getting vertical and horizontal lines. Shouldn't be anything new to SolidWorks users. I'll put dimensions on it. How you make a block is you can select the sketch geometry. I'm just going to do a box selection around here, so I pick it all. Right from my shortcut menu, I get the ability to make a block out of that. You'll see the dimensions disappear. They're still there. They're just internal to the block. Same with the relations. If I want to edit that, I can right-click on the block, choose to edit that block, and I can go in here and monkey with the numbers or put in more geometry, take out relations, put in relations. I exit out of the block, and I'm back in the sketch. And you'll see that that block moves as a unit. So I just drag this over and apply a relation. You'll see now I can see how this bar will swing inside of the assembly. Do that over here with this side as well. I'm trying to get it at least somewhere near where I think it should go. When it's underdefined, it's kind of a free-for-all as far as motion. You can just select items. I'll control select both of these, merge the points, and now I've got that joint. Allows me to see how this thing's going to open and close. And so now I can start taking measurements and getting lengths and getting an idea of what I need as far as geometry to create this landing gear. This first sketch is just a cross section of that hydroplane showing me where the weldment for the frame is going through. So when this thing goes up, it doesn't run into the pipes. Okay. Simple enough. Do you guys have any questions for me on that? All right. If you do have questions throughout this, do not be afraid to just pipe up. Pretty hard to throw off track. And I know I talk fast, but that's because I got a lot of information to go through here. So I'm going to build one of these arms for that landing gear. Let me just close out of some stuff here, make my software run a little faster. I'll open up an existing example that's already got some sketches for me, so you don't have to sit here and watch me sketch. Pretty simple example here. You will have lab time after this class if you want to go through it. This example is one of the labs, also that roll cage for the forklift. For everybody in GVC land, just ping me. I can send you the examples. Everyone who's here live, it's loaded on these machines that you see in front of you on the table. Let's get to it. I've got two sketches. This one's going to be a piece of plate metal. This other sketch is a skeleton of that A-arm that supports my landing gear. Let's just concentrate on this first sketch here. You'll notice that it only contains lines and arcs. Those are the only kind of geometry that you can apply weldment structural material to. If you need to do, like I showed you the hydroplane, I built the rib cage for that thing. That is definitely not arcs inside of that. That is spline geometry because I created it using some complex surfaces. What you can do, I'll show you a little later, is you can make a bunch of arc segments that mimic the spline to get your weldment done when you have complex geometry like that. Notice here for a second when I'm looking at my command manager, you know, you've got these tabs hanging down. If you right click, you can toggle on or off these tabs. I want to right click and make sure I've got the weldment toolbar turned on. And the weldment toolbar is where you access this weldment module. It is in the SolidWorks standard package, so you don't need premium or professional to do anything that I'm showing you today. Just a regular SolidWorks seat will do. If I click on structural member, SolidWorks comes with a very basic library. It's intentionally small. I'm going to show you in this example, or I'm sorry, later in this presentation, where you can get the full ANSI inch that has all the Z channels, C channels, I-beams, S channels, angle iron, everything that you could possibly imagine. But what ships with SolidWorks is much smaller. Let me set it back to what's just in the basics. So under the file locations, that's where the weldment profiles are called out. You see I've added all these weldment profiles here. I'll just stick with the one that comes with the original. Yes?
Does that also include metric?
It can. When I go over to this design library and I look at SolidWorks content, go into weldments, this ISO is all the metric. ANSI is all the inch stuff. It's also got Unistrut, and it's got all kinds of stuff. British, Australian, Chinese, German, whoever you're doing work with, they have their own standards. But yes, you definitely can get ISO and inch. But like I said, if you look at the ones that come shipped with it, it's pretty small selection, where it only has a few things and then only a few sizes of that. When you download the full library, you get dozens of sizes for each one of these and dozens of types of cross sections. And that's what it is. It's just a cross-sectional sketch. You can think of it like a sweep profile, because that's what it's going to do. It's going to take this profile. In this case, I'm going to do a 1/2 inch pipe. And when I select a line, you'll see here's the profile for it. It's just a concentric circle. It's been drawn down one of those lines, giving me a hollow piece of pipe. When I select another line, you'll see that it automatically miters it for you. The same would happen with a sweep. If I were to do a sweep path that had an angled section in it, it would give me a miter. But weldments does so much more than that. Not only can you do miters, but you can do underlaps or overlaps. You'll see how it cuts the fish mouth right into the pipe for you where they meet. You can also do weld gaps. So some space to put your weld in there so that the weld goes on the inside and the outside of your member, that sort of thing. Also, you don't have to hammer this stuff together. It gives you a little wiggle room. So I've just made a group of weldment structural members. They hit each other. I've told it, okay, I want a gap between those. If I'm still going to use the same cross section for that arc, I can just say, let's do another group and pick that arc. When you're working inside of groups like this, it automatically trims to one another. If it was a different cross-sectional shape, that would not happen. I'd need to trim manually. But because I'm using the same shape over and over again, it realizes, well, you don't want these to penetrate one another, so I'll cut them for you. And you'll see that the end of that pipe does, in fact, conform perfectly to the pipes around it. If I isolate this, it's actually a little too perfectly. You see that very sharp point. Not only would that be dangerous to handle, but it'd also be really difficult to manufacture. So let me go into this feature again. And when I select the second group, earlier I was setting this gap, which is the gap internally to groups. So in group 1, it's got a 2 millimeter gap. This G2 here in my property manager, that refers to the gap between groups. So you can control internal gaps and gaps between pieces when they meet. You can do a bunch of pieces at once using those groups. And that is the very basics of weldments, at least using these structural members. Is that pretty clear? Do you have any questions on it? All right. Next thing I want to do is I want to build this piece of plate steel. I'm going to extrude it, just like I was doing a regular model, but notice my merge result is not checked on. When you use a structural member, it automatically throws a flag into the part that says this is a weldment, and it turns that merge result off for you automatically. It does a couple other things. If I look at my feature manager tree, this is how it flags it. This weldment feature right here, right at the very top of the tree, will tell you this is a weldment. Also, I've got a cut list here that it starts making for me automatically. Right. While you're in an extrude tool, you can right-click somewhere in the blank area and change the end condition. I want it to go mid-plane. There we go. Now, it didn't carry off that gap. You'll see that right now, the pieces of metal are actually penetrating into that plate steel. We'll trim those up manually in a minute here, because I want to put in another part. I've got this piece of plate steel that you can just extrude plate however you want it. It'll just add a new list to the cut list items. If I update this cut list, it'll keep track of what's made using structural members. It has this little weldment symbol in front of it. And what's custom. If it's in a folder, it means it's some shape that you made yourself, but it still retains it as an individual cut list item. The next cut list item I'm going to do is I'm actually going to bring in an external part. So I'll type here on my search command bar and say I want to do an insert part. And I'll insert this machined lug. If I just click my green check mark right now, it's going to drop the inserted part into my weldment origin on top of origin, so they have the same 0, 0, 0 point. It'll ask me what I want to bring in. Do I want to bring in the reference geometry or cosmetic threads, any of this information? I'm just bringing in the solid body. Since I don't actually want it at the 0 point, I'll turn this check mark on, and right when I drop it in, SolidWorks will say, oh, let's locate where you want that. I'm also going to check on this break link to original part. This has to do with external references. If you've ever built anything inside of an assembly, you've seen external references before. Basically, it tells you that a part needs some other geometry from another file to locate itself or build itself. And what happens with external references is every time you open up a part with external references, it'll go and look for that external part. So in this case with the lug, if someone's still working on it and machining it, if I leave this checked off, it'll still have the link the next time I open my weldment. Any changes the guy did will propagate into my part. which is great for R&D, but usually when you release stuff, you want to take those external references out because you don't want things opt to change after you've actually put them into, the process of being manufactured. Yes, sir.
I often make parts with pins put in them, and then so every time I open that part, it always opens the pin part too. It drives me nuts. Is that why?
That is why. It's because it's got an external reference.
Right.
I can show you a little later a couple of things. How to not have external references in the first place. Also, there's a setting where you can say don't open it in the background.
That would be good.
Because you're just tired of the window always being there.
Yeah, because I do modify the pin, so I need to be able to
have
updates.
Reference?
Yeah.
Okay.
Thank you.
Yeah, it's a setting. Once I drop this in, I'll show you where that is. But I'm going to turn this thing on to break link because I don't want the link anymore. And if you have a broken link, what it'll do is it'll just retain its shape forever how you saved it. It's never going to look back to the original part. So I'll hit my green check mark, and as advertised, right away, SolidWorks wants me to locate it. This button down here, it says constraints. I can do it as if it was a part in an assembly and put on mates like concentric and coincident. Or I can toggle over here to translate, rotate. I only get to translate or rotate. You'll see that if I choose to rotate this thing, it'll show me a little preview of it rotating. And then I say, okay, I want to rotate a little and translate it. It goes right back to its original position. That's because you can only do one at a time. You either get to translate or rotate. If you want to do both, you have to do one, and then in another feature, you do a move, copy body, and do the other feature. So just to let you know why it doesn't let you do both. You can do both, you just have to do them as separate features. So I'm going to locate this thing over here. I don't actually need to rotate it. Back to your question, on external references, here's the where you want to load. If you say none, it'll never load that for you. It still does it in the background. It just doesn't open it in its own window. So it's still in your RAM so that it can update it, but you don't have to keep closing that window. If that's the thing that's bothering you, that's the setting that's doing it. All right, so I've got another cut list item. You can do whatever you want to do as far as multi-body operations inside of Weldments. Just think of it, it's just a multi-body part. So if I need another one of these lugs, I don't have to insert it again. I can just choose to use this mid plane as a mirror plane and just mirror this body. You want to make sure that you choose to do the bodies. Don't try and do the features on this. SolidWorks will get confused and it will probably fail. With bodies, you won't have any problem. It's just taking that XYZ geometry and moving it over there. It's not trying to rebuild the feature. Notice that my cut list here, it also bumped that up to a quantity of 2. You see that in parentheses it says 2. So it examines what bodies you've got there in there. If they're the exact same geometry, it'll bump it up to a quantity of 2. If I right click and go into the properties here of any feature, you'll see that cut list items that are made with cross-sectional members, it keeps track of the cut length for you. I just wanted to go in here to show you that this one is 370 clearly, or currently. We'll come back to that a little later after we've done the trimming, and you'll see that it updates that as well. Not only does it say, hey, this is your original piece of pipe, but as you start chopping it up, it'll keep track of exactly how long that piece of pipe needs to be. Back in my weldment tool, I'm going to choose to do a trim extend. The bodies I want trimmed are these two. What I want to use as my trimming body is I can either use a face or a plane. If I use a face, it's going to shoot that plane out infinitely in all directions. You'll see that it actually cut over on this right-hand side as well. And it's flagged every piece on either side of that cutting plane. It used to take a guess as to what you wanted cut and what you didn't, but it was such a terrible guesser that they just took it out of there. So you got to tell it specifically what you don't want to keep. These flyouts are toggles. So if you click on something that says keep, it'll change it to discard. If you click on something that says discard, it'll change it to keep. So I can say, okay, these two little ends here, I don't want those. And away they go. You see that they can also have a gap geometry. I've already got it set to have a weld gap of 2 millimeters here. And notice what it means by trim extend. When I pick these two bodies and pick this face, it actually lengthened this one to go all the way to the face that I just picked. You can pick multiple faces like that. And so now I've got the two little pieces on either side of the face and the two long bars on the other sides of the faces. I just tell it which ones I want to get rid of, and presto, they're gone. Let's take a look at that cut list item again. Remember it was 370 before, now it's 334. It also has the angles that you want to cut it at the ends. And the length that it's giving me is the overall length that I'm going to need before it cuts those angles off either side. So it is the true piece of pipe that I need. I've put in structural members. I've also put in custom pieces, things like plate or machined items. You can drop those into your weldments as well. The final thing I'm going to do here is I'm going to create some reference geometry. I'll do a plane on this pipe, parallel that top plane. And now I've got a plane that's sitting right on top of the pipes, which I'll use as a sketch plane. What I'm going to draw here is I'm going to draw a couple of parallel lines, and then I'll grab the silhouette edge, which is the edge of that pipe as I'm looking straight down on my sketch plane. You see, there's those two lines that I just copied off the edge of the pipe. And I'll trim this up. Whoops. Going too fast. Let me try again. Trim. There we go. Just around so that I've got this trapezoid. Now I'll right click on my tabs again and bring up that sheet metal tab. So you can build the piece of sheet metal right inside here. Next month, we're going to have a class on sheet metal, just sheet metal. So I'll get into a lot more stuff. You can do multi-body design inside of sheet metal if you want to do a box and a lid. You can do them in the same part, and then you know that they fit together. And it uses this same weldment type of geometry here. So I picked to do a base flange. I want to make sure I'm going the right direction. Here's where I pick the gauge. I say, okay, that's nothing too spectacular. I could have done that as plate metal. But with sheet metal, I can also start adding flanges and things like that. I can also tell it whether I want to go the inside of the edge, the outside of the edge, or one bend radius out. That should give it a nice snug fit over my pipes. All right, so that was me building a weldment. Take a look at the cut list here. Again, we've got structural items. We've got these folders that are custom shapes. And then this symbol right here is a piece of sheet metal. If I select on the sheet metal, either in the cut list or just in the graphics area and hit flatten, it'll show me the flat for just that piece. And a little later, I'll show you that you can actually, when you're making drawings, you can break this out and say, just show me the sheet metal. Just show me this sheet metal body, just show me that sheet metal body, show me the flat for it, make a drawing of it without having to create it as an external file. Okay, as I'm cleaning this up here, do you guys have any questions on how I built this part so far? Hopefully Adam's still okay and with us on GVC. All right, if there's no questions, I'm going to start getting this thing ready to make a drawing out of it. I'm going to go into the configuration manager, and you'll see that it actually built configuration for me. That's an option. You can have a configuration where it's machined and then another configuration where it's welded. If there's some sort of post-process stuff that you're going to do, it automatically puts in a derived configuration. So changes to this will affect this part as well, but you can have sort of two nested versions if you want them. That is an option. If I go into the document properties and weldments, here's the default options that SolidWorks does for weldments, where it automatically creates that cut list, updates it for me. And here, this third one is where it's creating that derived configuration. So if you don't want another configuration, you can turn it off. You can also, the folders that it's showing me for those custom ones, you can have it automatically put that in as the description property of the weldment body, which will make more sense to you when I get into the cut list in a couple seconds here. But while I'm in the configuration manager, why I came in here is I wanted to actually create an exploded view out of this. So you can create exploded views out of multi-body parts. I believe that was new in 2014, somewhere around there. So all the versions of SolidWorks that Google's using currently are able to do this. I'm going to go into my isometric view and just start pulling this thing apart. So it works the same way as an exploded view for an assembly, where you just select the item and then move it along the X, Y, or Z, however you want to do it. Now I've got an exploded view. If you double click on the exploded view, it explodes or collapses. You can also right click, get the same sort of thing happening. So that's one thing I want for my drawing. The other thing I want for my drawing is this cut list. I already showed you that you can right click on any item here and go into the properties, and it'll show you what properties it stores for each one of these cut list items. For items that are made using structural members, it automatically has a description of the structural member. The ones that are made using sheet metal, it automatically puts in a default value, a description called sheet. For this item 4 and 6 here, it didn't really do much of anything. It's just got the material in there. When it comes to the material, by default, they'll all be set to whatever material you've got set at the top level of this part. So now they're all saying that they're plain carbon steel. I can also, this gives me a list per cut list item. So I can go item by item, or I can check out property by property. So if I want to see, let's say, the material on all of them, currently they're all plain carbon steel. If this is a true weldment, usually you're going to want to use the same material throughout so that they weld together nicely. But you can, as I said, use sheet metal geometry in here, and sometimes you'll have an aluminum piece of sheet metal, maybe with steel PEM nuts pressed into it or something like that. This is where you can override the material value for a particular body, if you want to do that. And that's what will be shown if your cut list has a material call out. We go into the description one, because you'll see that the sheet metal automatically just says the word sheet. I'm going to extend that to say actually the word sheet metal. And for this one, this is the machined lug. And this one is the plate. The steel plate. I say, okay, and now it'll retain those properties. If I go back to the description, it's got these names in there. Oops, didn't save this one, but I can always retype it. There we go. So this one gives me cut items. This one gives me the properties. This last one shows me the cut list itself. If you don't have a template called out, it'll give you that warning. You can just press that little star button. It'll take you to where the default one is stored. So this is what my cut list is going to look like on my drawing. It'll call out that I need 3 pieces of pipe, tell me what length of pipe I need, 1 piece of steel plate, 1 machined lug, and some sheet metal. So you want to set that up before you make your drawing. Now I will make my drawing. Just pick a B-size template. Drag in an isometric view. See, because I have an exploded view, it gives me the choice to do an isometric explode. And make that one shaded. Or I can do top views, bottom views, whatever I want to do. If I right-click on a view, I can choose to put in that weldment cut list. So instead of a bill of materials, use a weldment cut list when you're using a cut like that, and there you go. There's that cut list that I was playing with when I was at the part level. It does give you each item as a fine number over here, which you can go into your annotations, start attaching balloons to. If you want a balloon to have a quantity, you can do that as well. You can also do an auto balloon. I can select this view, say let's do an auto balloon, and it'll put balloons on anything that doesn't have a balloon on it yet. If they're together, it'll give it one of these magnet lines. You can move it over, put it at an angle. You can attach another one if we want them to be nice and in a row. Now, obviously, because this thing is welded, I'm also going to want to put in weld symbols. You can do that manually. I can select a place weld and call one out. Any type of weld symbol I want here. And put whatever notes I need on it. So it's a pretty robust annotation. If you double click on it, it'll bring that back up. If you need to have welds on the other side, they'd go up here. There's other sorts of symbols you can put in here. If you put a note in this back, it'll put the tail on. But if you take that note out, the tail goes away. But let me show you another way of doing those types of annotations. I'm going to go back into the part. Under weldments, there's this choice for a weld bead. and this is an annotation. If I go into my command search here, there's another type of bead you can put in called a fillet bead. Here's the difference between the two. A fillet bead is not an annotation. It'll put in a solid body for you. So what happens with that is if you start putting in fillet beads, it's going to start adding items over into your body list over here. The only reason you'd really want to do a fillet bead is if you're checking for total weight and you want to put those bodies in there. If you've got a ton of welds and you're worried, hey, this thing's got to fly in the sky or go into space or whatever we're doing here at X. If weight is a crucial consideration, you may want to put those fillet beads in there. They also help a little bit with analysis because of these gaps that we've got going here. They're not actually touching each other. But
why did they just make them one thing?
Well, because you don't always need to have the solid body in there. The solid body is really kind of overkill for what most people need from their weldments. What the fillet bead does for you, if I pick a face here, pick a face there, it puts in your weld call out and it puts in a graphical caterpillar, sort of a 3D caterpillar in there to show you where the weld goes. But it's not.
It has no mass. It has no physical properties.
Right. And so it keeps this body, because this cut list is really just keeping track of a bunch of bodies.
Mm-hmm.
If I put in 6 more welds, I have to go in there in the cut list and clear all those out and say, don't show these as cut list items. And it gets a little bit more top heavy than I need. The only time, like I said, that I've really seen people use fillet beads is if they're overly concerned with weight. Otherwise, these weld beads do what you need. Graphically, the part looks like.
Or what if I had to take this and export it to do FEA?
There's different ways of doing that. So if you were actually trying to find out the strength of the weld itself, you may want to do a fillet bead.
The whole structure.
But when you're just doing the whole structure, inside of simulation, you can call out pieces come in contact and fill out the contact as a weld.
But I want to export it to ANSYS. Then I'd have to go in and make stand-in parts. I'd have to do the.
So you could do the fillet bead for that if you're going to be doing that. Yeah. You'd probably want to do a configuration with that, just so you have one configuration that's fully loaded for FEA, and then another configuration that's easy for you to get a clean cut list out of. All right, so on the weld beads, how these work is I select the 2 separate items that I want. Say, okay, if you hit your enter key, it takes you into the last tool you were in. Say SolidWorks general shortcut. I'm just hitting enter here. I've got all of those in the part at this point. So I'll save that change. Use my control tab. Switch windows. Now it didn't put anything in there because I haven't asked it to put anything in there yet. If I select on this view and say, let's bring in the model items, I can choose to bring in whatever annotations. So it'll put in the weld symbols and these caterpillars for me automatically. If that wasn't the type of weld I wanted, you can just double click this and change whatever type of weld you want in there. There we go. Now I've got this pretty detailed annotation here as far as what pieces I need and where I want them welded together. I can also bring in views model by model. So if I go to my view layout and say, let's do a model view. If I select an item that has multi-bodies, you get this select multi-body choice over here in the property manager. When you pick on that, it'll take you into the model and ask you, what bodies do you want to have shown? You can pick bodies that you want to make a drawing view of. I'm just going to pick this one piece of pipe here. And drop it. So now at this point, I can put in annotations for, let's say, the length of this, or the angles that the ends are cut at. Help the guys machine this thing. That works for the sheet metal part as well. Go to model view, pick this part that's got multi-bodies. So I want to select a body. If I pick that sheet metal, I get the different views I can do, but it'll also generate a flat pattern for me. It takes a second after you pick that because it's actually got to go into the model and generate that flat pattern for you. But once that's built up, now I can go in here and I can start annotating, how this piece of metal is supposed to be created. Whether I want to do overall dimensions or ordinate dimensions or whatever I need to do, I can start giving them an idea of what that sheet metal looks like. So, all right, that was the long example that shows you how to use the weldments, structural members, how to put sheet metal on there, create a cut list, a detailed drawing. This is the one, if you have time after the class, you can go through it in a lab where I've got the step-by-step instructions. But do you have any questions for me on any of the things I just covered?
I have questions on welding of sheet metal. So should I hold off on that for next week's sheet metal class?
Probably. You're talking about like welding the corners,
Yeah,
things like that. Yeah, we'll cover all that in the
Great.
sheet metal class.
Thanks.
Or if we have time after this class, I can cover it
Wait
for
for
you
next
too.
week. Sounds good.
Okay. So I have run through most of this stuff here. So I'll close these guys out. Bring up my next example, which would be this part here, which is not yet a weldment. It's just a couple of pieces. You recognize the lug there, and then here's the end. This is that bar that when I was doing the conceptual design, I was trying to do that like knee joint. This is one of the legs of that knee joint. You can make any part a weldment part. It's pretty easy. See, it does not have weldments. It just has multi-bodies at this point. But I press this weldment button. Now it's been turned into a weldment. It keeps track of cut lists. It'll start giving me quantities on my bodies and things like that. So you don't actually necessarily have to use structural members at all to create a weldment. You just hit that weldment button and it turns the part into weldments. Now, when I extrude stuff, it doesn't merge. When it finds volumes that are the same in bodies, it gives me a quantity in that cut list and also generates a cut list. What I want between these two pieces is I want to put a solid bar. Right along here. Don't actually want to hit that midpoint. There we go. So I want a solid piece here, but if you remember in my weldment structural members, that is pipe. I don't have a solid shaft in here. So I need to create my own weldment profile. And you can make any shape you want into a weldment profile. Here's how you do it. It starts life as a new part, so open in whatever units you want to do. And in a sketch, you draw a profile. In the piece of pipe that I was using, it had concentric circles. If I just put a solid circle in there, it's going to sweep a solid shaft in there for me. You can only select vertexes or points within the sketch to run the sketch down. So if I want to use the quadrants, I actually physically have to put in, I'm putting sketch points in here. I can put in sketch points. You can also put in construction geometry. If you want to have more choices for places to snap things to, I'm just going to, if I right click on a sketch that's like a square and say select chain, I can pick all of it, turn it to construction geometry. Now I can run my sweep down these points as well. So now I've gone from having one point, which you get for free as the center point, to having the center point or 4 quadrants or these 4 sort of virtual sharps on the corners. How you create your weldment profiles, you need to save this out, but you cannot save it out as a solid part, and it's not going to work for you. What you need to do is you need to save the sketch as a library feature. The very first step in doing that is selecting the sketch itself. So you pick out, okay, this is going to be my library feature. I'll do a save as, and rather than saving it as a part, I'll save it as the second choice library feature part, or SLD LFP. I'm going to browse to a folder where I've been saving these shafts. It tells me, hey, I'm just saving the sketch in here, so if you had any other geometry, it's going to simplify it down to just being the sketch. My part has changed. First off at the top, it says SLD LFP. Also at the top of my feature manager tree, this usually has this part icon here. Now it looks like a set of books. Also, the sketch itself has a capital letter L on top of it, showing me that that is the actual library feature that's saved here. Now, in order to access that, I need to go to my properties. I go to File Locations. I can set up where the weldment profiles are coming from and add a location. Notice here that I've actually got the full ANSI inch and the unistrut saved out here. Those are files that I downloaded from SolidWorks libraries. Also notice the ways they're set up. You need to have a top, which is where your profiles are. The second folder is going to be your standard, and then you need to have subfolders in that that actually contain the different cross-sectional shapes that you're after to get this to work. So you need to have this 3-level folder setup for the trick to work. Now, where I got that full ANSI inch, I'll show you again over on the right-hand side. Click on the design library. You've got this SolidWorks content. You just hold your control key down. It shows a pop-up here, but I'm patient. Hold your control key down, click on this. It'll download the file to your computer. Not everybody uses Weldments, so they decided to save some gigs here and not put every cross-sectional shape that you could ever possibly want. You need to download those. So I downloaded, this is what you get, this zip file. Just unzip this into that wherever your weldment profile folder is. And then it's got full of subfolders with all sorts of cross-sectional shapes here. And you'll see that when I go to structural members, here's the ANSI inch and ISO that come by default. The full ANSI inch, much more choices. Also, once you pick a cross-sectional size, you get a bunch more choices. as far as sizes that you can use. Tons of them. Or you can use a custom folder like I use. I also downloaded this Unistrut, which is just Unistrut cross sections that Unistrut was kindly enough to put in there for you. It's a marketing trick because I figure if you're using Unistrut stuff to build your weldment, you'll build Unistrut. There is 80/20 information out there that you can download. It's not in the SolidWorks one. I guess they did not get a proprietary deal with SolidWorks, but I know that there's 80/20 cross sections out there too if you want to use those. Because the parts don't actually need to be welded. They don't even need to be metal. You can do 2x4s here and build a picnic table using weldments pretty fast. A doghouse, whatever you want to do. I use this custom choice and say, let's do that shaft that I just created. And there's my 1/2-inch shaft. Now, the reason I put these points here is you see that it defaults to whatever was the origin of the sketch. But if I say locate profile down at the bottom of my property manager, I can either use these quadrants that I set up or these corners. And you'll see that's how it draws the sweep down. I did actually want to use this centroid, but just to show you, that's how you can control. It doesn't always have to just go down the sketch origin. All right, so that's a quick primer on creating your own custom shapes and where to get the real shapes if you are going to use weldments. Using the ones that come out of the box, you'll find are very limiting. Any questions on that? And I shall move on. This next thing I want to show you is we're finished with the landing gear. It turns out landing gear makes the thing too heavy. It doesn't go in all the way. Forget it. We're going to just put this thing on a boat trailer. So let's build a boat trailer. When I'm putting in structural members, in this case, I'm going to put in rectangular tube. When you pick a single item, it just does that. And that's what I did in that last one that I was creating. I was just selecting one single item, but you can pick more than one item. Continue populating along a string. It just needs to have some sort of coincidence to it, where the lines are actually touching one another, or the endpoints are actually touching one another. I want to call attention to this checkbox over here in my property manager. It says merge arc segment bodies. If that's not on, it won't merge them. I have a straight piece, I have an elbow, I have a straight piece. Sometimes that's what you're after, but it is an option. If I go back into that feature, and this is just like any SolidWorks feature, you just click on it, say edit feature, change the property to say merge, and that's what it's done. It's merged them into one single cut item. So now it is a straight piece that has a bend in it. Just a warning, it's not as intelligent as sheet metal, where sheet metal you can actually put in a K factor or a bend allowance. It does not figure out the bend allowance for you. It does not stretch this metal at the bend like happens in manufacture. So be aware of that. The cut length that you get is the finished product cut length. So you may need to work with whoever your tube bender is to figure out the actual length that you're going to need to cut it to get it to stretch to the proper size. I'm going to go back into the edit feature because I wasn't done putting in my pieces. So let's do a new group, put in a piece here. You'll see that when you're doing them in a single group, it will trim automatically to one another. One more group here and there, and I realized, I'd rather have this thing 90 degrees over. Remember down at the bottom here, I was showing you that you can locate the profile. So if you want to use any of these points, a natural point like a vertex or where two endpoints meet can be used, but they've also put in some helpers here at the virtual sharps by putting in sketch points there for me. Not only can you locate the profile at any point that's inside the sketch, you can also change the angle that it's at using this setting right here. You can use the arrows, or you can just type in a number and say, that's what I wanted. Now I've got this thing standing on edge. Let me isolate this piece for a second, because take a look at how it did the trim. It trimmed to the body that it was going to, but because it wasn't hitting exactly at the flat face, it was hitting at the bottom a little bit, it left me with this little sliver. So even though it does do trims naturally, like it trimmed here and it trimmed there, sometimes you want to take a look at what it did. See how it's trying to trim right up to that face, which I'd rather not have that really sharp point on the end of my structural member there. So you can do manual trims after the fact as well. I can say I'd like to trim this thing up to this, discard that sharp point at the bottom.
I mean, it dips down at a plane? Is that why I did that?
Yeah, if I roll back to before I trim this, see it's going
Z or X maybe.
It's because it's trimming to this face and this face of the body.
I guess I'm trying to figure out why why I didn't do this on the top, and it's because this added member is out of plane with the original system, right?
Right.
Yeah. Okay. Now I see. All right.
Okay. You can mix and match structural members. I can use that custom shaft that I created earlier for this piece right here. When you're not doing groups of the same member, they don't trim automatically like the pieces of rectangular tube were. You see that because I picked this line, it just gave me cross-sectional member all the way down the line. It didn't take a look at what was around it. It just does what I asked it. I said I wanted it to populate a shaft down that line, and it did it. So I gotta, when you're mixing and matching structural members, you're gonna need to do the manual trimming yourself using this trim extend tool. In the past, I've only been doing face and plane types of trims. If the other body in question was created using a structural member, you can actually just say, I want to trim to that body. You'll see that it doesn't give me that whole discard keep stuff on either side. It just says, okay, where it hit that body, that's where the thing stops. And the reason I say you have to do it with structural member, if I had extruded a plate or something like that, I couldn't just use the body of it. I would need to pick a planar face on it to trim. All right, this is not looking like a boat trailer yet. It certainly needs more stuff on the other side. I showed you earlier that we can do bodies to mirror and mirror items to the other side. When you do a mirror like that, just the regular out-of-the-box mirror, it keeps them separate. I've got a quantity of 2 on this one, quantity of 2 on that one. Move this out a little more so you can see it. It's adding them up, but it kept them independent. It didn't merge them together. You can merge them together if you want to. This is to double the size of it. Like in this case, this is only half of what I need. So I will mirror this body. If I say okay right now, I get 2 pieces on either side. If I check this merge solids, I just have 1 piece. So it merges both pieces. So if you actually want to double the size of the member, you turn on that merge solids, and it's still smart enough to know, oh, this is a piece of rectangular tube, and it redoes the length for you, doubles the length automatically. So you can do patterns. You can also you can do mirrors. You can also do patterns. Again, you want to make sure that you choose to pattern the body. And then just tell it how many of them you want, how far apart they're supposed to be. And you get something that looks more like a boat trailer. Okay, so the concept on that was showing you a little bit more on trimming, also showing you the fact that you can do a mirror to duplicate a part, or you can do a mirror to double the size of the part. Any questions on those concepts? All right. We'll make a pretty good time to do this. I only have a couple more examples that I want to show you. I want to build that roll cage that was on top of the forklift. And I also want to show you how to make a more complex shape of a weldment, like the structural skeleton that was inside of that hydroplane. Oops, I don't actually need to open a part here. I'm going to start one brand new from scratch. When I go to the weldment toolbar, you'll see all the way over on the left has 3D Sketch. There's a 3D Sketcher inside of the regular Sketch toolbar as well, but 3D Sketches are a very popular thing to do weldments with because you can build the entire skeleton in one single sketch. Earlier, what I've been doing for my designs is I've been using a series of 2D sketches at different planes to one another. But for this one, I'm going to say, I'm going to do a 3D sketch. When you're sketching in 3D, it's a little more difficult than sketching on a 2D plane. On a 2D plane, you have all of your planar Euclidean rules where you can have horizontals and verticals pretty easily. In 3D space, there is no horizontal and vertical. There's a long X, there's a long Y. It's a lot harder to get stuff to go parallel and perpendicular and things. They're free to move in any direction. You're not held to a single plane like you are on a regular sketch plane. When I start drawing a line in the 3D Sketcher, notice next to my cursor it says XY. That means I'm sketching along this XY plane here. I can change that later on if I want to, just by hitting the Tab key as I start drawing that. Now I can go out into the Z. Or along the X. So this is pretty easy when you're doing orthographic type of design here. Well, I want to go straight up, I want to go straight over. But if you draw a line just any old place, and then you start dragging it around, notice when I'm dragging it, see how it's building this yellow cube? That's because it's moving in 3 dimensions at once. It's going over and up and across. And it makes life a little more difficult as to figure out exactly where is this? Is this thing at this point pointing out towards me, or is it going away from me? I can't really tell because I'm looking on my screen at a 3D sketch. If I rotate it, I get an idea of where things are, but once I start moving this around, I can lose track of where am I in real space. Some ways to help combat disorientation that you'll get sometimes when you're doing design. You'll notice that if I click an endpoint on one of these lines, I have an X, Y, and Z component of where that point is in space. I can type in numbers there. Now this thing is sitting flat on the Z plane, or along the Z. And if you've ever noticed this origin down here in the lower right-hand corner, it's called your reference triad. If you select on that, it'll look straight down whatever plane you selected. So right now I'm looking straight down the Z-axis. When you're looking straight at a view, like a front view or right view, top view, something like that, where you're looking straight down an axis, when you go to move an item, look over here on my feature manager. The Z isn't changing. I'm only moving it in the X and Y. If I change over in this direction, now the X is not changing. I can change the Y and the Z. So oftentimes when I'm trying to get things located properly inside of a 3D sketch, it's good to use the views and make sure you're only going in two directions at once, just so you don't get discombobulated.
So does that mean it has some proportionality rules? It basically moves a point in the plane normal to your viewing vector.
Exactly. So it can be out from, it's not at the zero really,
Right.
but it's like you said, it's moving it in plane to how you're viewing it.
Right.
It's not going to go back and forth on you.
So if you went in a perfect isometric view, so to speak, it would be moving equally in all three X, Y, Z at the same time.
No.
You weren't looking.
When you're in an isometric view, it's a free for all. It's moving in all three at once.
If you're looking like straight down like that.
No, it only works when you're using diagonal views.
Okay.
So if I'm looking at the front view, because I'm looking straight down the Z-axis, it's not going to move in the Z-axis.
So there's a situation where I needed to move in a particular plane that's not purely an XY plane. I couldn't control that plane. I mean, that's not purely XY or ZY or.
How I will typically, if I've got a situation where there's a couple ways of doing it. One, you could actually build a plane out there and
Right.
lock the point to the plane.
Right.
Or what I typically do when I'm working in a 3D sketch, especially if I'm working with something like a spline that's really difficult to control in 3D space, I'll change how my view looks. If I go up to the pull down here for window and change to 4 view, when I move stuff here, it's only moving in X, Y. When I move here, it's no longer moving along the Y. When I go over here, it's no longer moving. And I can see in here, it's actually happening in 3D space. So that's the best way to try and get some sanity in what the heck is going to happen if I drag this thing. Get an idea of, okay, I only need to move in plane. But if it's some plane that's off of it's not in the regular quadrant system, the front, top, and right, it's much tougher to control without actually creating plane geometry, which is what I'm going to do here for you now. And maybe this will show you that you can pretty easily do some other tricks as far as, okay, I get the idea that it's tough to move inside a plane, but what if I do want to be in a plane? I'm in a 3D sketch right now, but if I double click a sketch plane, see how it puts that graph over there? Anything I draw right now is automatically attached to that plane. So all of a sudden, now I've got things like horizontal and vertical again. I've got the ability to do mirrors now because I'm on one single plane and it can easily figure out what's going to be mirrored. So I'll flesh this thing out with some dimensions. When you're dealing with a weldment sketch, you don't have to be so paranoid about things overlapping. Like when you're doing an extrusion sketch or something like that, you always want to make sure you don't do this, where we have a line on top of a line. But because we're only using pieces of line and not actually extruding the shape itself, you can get away with this in a weldment sketch without any ill effect. So what I'm drawing right now is the top of the page for that forklift. That's all I wanted to do on the top plane. All I need to do to stop being on the top plane is just double click somewhere in space. I can create a reference plane here that would be external to the sketch itself and connect other things to it, because right now I want to have stuff that's along this flat plane right here, dropping off the side of it. You can also build planes inside of a 3D sketch using this tool right here. A lot of times I like to use external reference sketches, so I'll do them myself before I build the 3D sketch, just because I have something outside of the sketch that I can use. But when you build one internally to the sketch here, this plane only lives in this sketch. So to move it around, I have to actually edit the 3D sketch to get to see this plane. But the pluses that I have from doing an internal plane is, one thing is it automatically, when I build it, it's ready for me to start sketching on that plane. Also, later on, if I want to copy and paste this 3D sketch, I can do that and the plane comes along for the ride. So I can copy it out of this part, paste it, I get the 3D sketch on all the internal planes that were inside it and things like that. So there are reasons sometimes where I will want to use 3D sketch planes like that. But now everything I sketch, I know is on that plane. So when you were asking me earlier, well, what if I want it to be on that plane? You can create a plane inside of the 3D sketch and stick the endpoint of it to there. And then when you start dragging it around, you know it's always planar. Okay, so I'm going to put the dimensions here on this one. And now I've got half of this structure planned out. You always want to take advantage of symmetry whenever you can inside SolidWorks. Make your life that much easier. Then I'm going to extrude some shapes. Use that rectangular tube again. I do want to show you something that, take a look at, it's ending at the line, like you would think it is, like you think it should. When I go to the new group, click here, it extended further so that it comes flush with this end. That's because I'm inside the same group. It's got that trim extend turned on automatically. So it automatically extended it out so that those two pieces were flush with one another. The items that I want to fill out in here, I do want to cut some stuff away. There's different ways of doing cuts inside SolidWorks and inside Weldments. If I do an open contour, something like this, when I choose to do a cut extrude, it'll automatically cut everything to one side. I use this flip side to cut to determine which side it's going to cut away. Or I can also do a closed contour, like a square or a circle, or in this case, a triangle, where all the line points or segments match up with one another. If you've got a closed contour like that, and you do your cut extrude, it'll cut that shape through whatever you've got going there. I'm just doing up to next here. Take the front off of that thing. Okay, again, mixing and matching structural members. I'll set this thing to use that custom shaft size that I developed earlier. We're going to have a bunch of those along the top. And again, when I select on that body, you can see that it goes through the pipe here and through there because it's going all the way along that line. It doesn't do that trim extend when you're not doing the multi-group type of design like I was earlier with the rectangular sections. So I need to trim this myself. I want to trim that shaft, and I can use multiple bodies to trim it to. So now when I look down these, you'll see that it's cut everything out of the inside of those bodies for me. Any questions on how I was able to develop this using the 3D sketch or the multi-body structural members? Then I'll quickly run through some of the old tricks I showed you earlier. I can use a planar face as a body I want to mirror. I want to merge these solids. So I double the size on that. Do a linear pattern here. And always do it for the body. So I want these metal shafts, a bunch of those along the top, keep anything from falling on this guy's head. Before I mirror the other sides of the legs here, I want to do some finishing work on this because I haven't covered all of the weldment tools yet. I've covered all these: 3D sketch, weldments, structural members. I did the trim extend. This guy, extrude, cut extrude, hole wizard. These are the same as the solid features of the same name. It's on your features tab. Extrude, cut, hole wizard. They just put them over here for convenience. The only new stuff that I haven't covered yet are end caps and gussets. What an end cap will do for you is if you select the face at the end of one of these structural members, it'll put a cap on top of it, like the name implies. Here I can set what thickness I want that end cap to have. Also, as far as offset value, you can do it by ratio of thickness. So this is 1/2 of a 1/4 of an inch. This is 1/4 of an inch. 3/4 of an inch, and that's offsetting from the side faces of here. So you see that the smaller the number, the closer it gets. So you put a 0 in there and it's right flush with it. You can also just do a numerical value. You can also knock the corners off here. Either put chamfers on them or fillets, it's up to you. And you'll see that it's knocking the corners off of that. There's a couple different ways to do these caps that sit on top of the first choice here is outward. If I choose this next one, inward, what it does is it trims off the end of that member to whatever thickness is. So the new end of the member will be here. Or here, it'll be at the end of the face. And what that does for you is now this flat face is the same, what used to be the end of that member. So you still get the same overall length when you put the end cap on there. It doesn't add plus the end cap. It subtracts however thick the end cap is from the member to give you the same overall length. The last choice on end cap is this internal option. So with the internal option, it actually sticks the end cap inside of the part. So it's still the same length, but you see it just plugs that hole with an internal cap. The other type of item you can do is something called a gusset. Sort of like a weld bead, where you pick the two faces that the thing's going to straddle. And then I can pick how far down this goes. Down one edge, down the other edge. And it puts a gusset in there. You can take the inside out of this gusset if you want. Lighten the load a little bit. When you do the polygon choice here, it'll knock the corners off of this as well. So it doesn't have those sharp corners on the piece of plate that the gusset is made from. It will remember whatever settings you have. So if you hit enter and you pick a couple more faces, they're 6-inch, 6-inch, 2-inch, 2-inch. You see, it actually gives you different geometry because it's calculating the length from whatever angle you've got going here. And then I'll just take advantage of that symmetry that I had before, where I only have to build half of this, and then I can mirror the gussets and the end caps, as well as the legs. And there we go. A complete roll cage for that forklift. Any questions on how I was able to create this geometry? All right, then let me get to my last example. That is trying to build a weldment inside of something that is not prismatic or along the orthographic shape. Like that last example, it was pretty boxy. This one is anything but box. There's no linear edges. There's no arcs on here. This is all done with spline geometry created in our surfacing class earlier. I want to start populating a structure full of ribs and spars, cross members, bulkheads, all those kinds of things inside of this. To do that, first I'm going to find an actual bottom to this. If I look straight on, my top plane actually isn't right along the bottom of this. I'm going to create a plane a little bit. So if you hold your control key, you click and drag on a plane, it'll automatically offset a plane for you. You just type in how much of an offset you want. Now I created this plane because the next tool that I'm going to show you by default will always go to the top plane unless you tell it otherwise. So that's why I'm selecting this plane before I go into this 3D grid system tool. How the grid system works is it starts you on a sketch. You see, I get this little thing that says 3D grid rather than my sketch. In a sketch, and my sketch is on either the top plane by default or whatever plane I had selected. What this tool allows you to do is quickly build up a lattice work. So it's really great if you're building power towers, derricks, cranes, staircases, scaffolding, stuff like that. We've got levels and places you want to quickly put in sketch geometry. Let me demonstrate. So I'll look straight down at that sketch that I've got and put in a center line for myself. Let me do a dynamic mirror on entities on that center. Everything I draw on one side gets drawn on the other. If you take a look at, as I'm drawing lines here, I do want this to be a horizontal line. Try that again. As I'm drawing lines, it starts numbering them. It actually has some intelligence here where you'll see it's 0, 1, 2, 3. If I put one in between 2 and 3, this is now 3, this is 4. So I can put in as many spaces as I want to have these stations or bulkheads or whatever I want to call them as far as the frames that I'm going to put down laterally along this thing. You can also put in as many as you want. You'll see that if you create like where I want to have a wing structure, as long as you have horizontal or vertical lines, it'll also start doing a pattern over here where it's going A, B, C, D. So members all will get numbers. Anything that's along the horizontal will get letters to lay out this grid system for you. What it'll do with these shapes is it will extrude them as surfaces. So you do want to make sure that you don't have crossing geometry. You can't have a line on top of a line when you're doing this type of thing, because it's going to want to take that and extrude it as a surface. So it's got to have valid geometry for creating surfaces. But what happens when I use this sketch tool, the next point it'll ask me is, how many levels do I want? So if you are doing like a scaffolding or something like that, you'd say, oh, I want to do this 6 floors high. You can put in however many levels you want. Here, this is pretty short, so I'm only going to do 3 levels. You count the original. So I've got the 0 floor, floor 1's 400, floor 2 is 400. See what it does for me? It takes that sketch geometry and copies it at every level. Also, what it's done, hide some of this stuff just to make it a little easier to see what's going on, is it's created a bunch of surfaces for me. So there was the original surface body that I had, but it also created all these planar surfaces for me. They're planar because I drew lines. They'd be a curve or a cylinder if I use arch. You can use any shape you want in here. But what it does is it just extrudes it out, and now you've got a surface showing you sort of where your bounding is. And you can also use these surfaces as sketch planes. I'm going to offset this surface. I'm going to bring up my surface toolbar here. Offset it towards the inside. Oops, I shouldn't have done that because it's not going to be able to actually offset these tips that far. So I don't want to actually do the entire one. I just want to offset these. It would have a problem offsetting these to the inside because it'll start running into itself. Okay. So I'll hide the original one. I've got this smaller one. This is where I'm going to have those created. I'll do a nice shortcut here. If I go into my sketch tools, I showed you convert entities earlier where I was stealing the edges off of those tubes. Convert entities, you take some geometry and say, I want to copy it over into whatever sketch I'm using now. If you're in a 3D sketch, it just takes it where it's placed. If you're in a 2D sketch, it projects it onto your sketch plane. Underneath here, there's also a choice for intersection curve. If you're in a 2D sketch and you do an intersection curve, you can have it show you the curve where a face, a plane, or a surface crosses your sketch plane. If you're not inside of a 2D sketch, it'll create a 3D sketch for you. And I can pick where I want these things to run into one another. I'm sorry, I want to know at all these stations, where do they cross that plane? So this is set up for me this system of sketches. You can choose to show less these sketches. You want to hide things a little bit, see more clearly what the heck's going on. There we go. See, what's left behind for me is these splines where those stations crossed the surface that I had for the outside of this kayak shape. Let me find one of those surfaces. That's the one I'm after. Because I can use those planar surfaces also as sketch planes. You can just pick on one and say, let's do a sketch here. Draw a center line. Start using this tangent arc tool to trace over the spline. And you see it shows me when I'm inferencing it. So I can get pretty good, pretty fast, where exactly this thing crosses the line. Now if I mirror this, make these two tangent down at the bottom, I've got this shape. You can play around with exactly where it is to overlay it over that spline. Because as I told you before, you can only use lines and arcs to create weldment geometry. So what I did was I just got myself a spline and then traced over it with a bunch of arcs. That gives me the power to take this structural member, hide that 3D sketch so I don't accidentally do that, and I can pick whatever piece of pipe I'm after. In this case, I'm going to do a 1-inch piece of pipe. And as long as I've got the merge arc segment bodies, it'll give me one continuous piece of pipe here. There we go. So I've got my frame. I'll also start a sketch here. Go into this. And actually start grabbing the inside edge. silhouette edges of all this. Pretty click intensive, I know. I'm just going to show you one example here so you get the idea. Looks like I did not get all the lines after. That's okay. I'll just cheat here for time constraints. Should be good here. All right. Actually, a better way to do this, if you do convert entities, if you pre-select it, it's only going to do the ones that you have selected currently. But if you select it firsthand, you can see where it's going to get them. That should do it for me. Oh, did I draw a? Oh, I apologize. I believe I'm working on the sketch for this line. I don't need. I had that surface selected. Let me try that again. Perfect. Okay. Sorry about that. I can create this sheet metal. And what I had done is when I did convert entities, I still had this surface picked, so it had interior and exterior stuff. But there we go. Finally got it after a lot of clicking. And I've got that pipe, got that piece of sheet metal. This pipe would be interesting to make because it's like a Mobius strip where it runs into itself. Obviously not going to work too well. So what I'll do is I'll create a sketch on this plane. You'll see that when I do the intersection curve for a plane that I'm currently sketching on, you do that intersection, it just shows you where that surface intersects the part that you're after. Or, I'm sorry, the plane that you're after. Now with this, again, when I created this geometry, it's coming in across as splines because that was not an arc that created this shape. So I'll turn this to construction and overlay an arc that pretty much hugs that spline shape. Because I'm going to put a keel on this thing, using a piece of rectangular tube. now I'm starting to build that framework that'll fit perfectly inside that. I can use my trim extend tools. I want to trim this thing. Using that part, that'll snap that piece and weld it to there. And this all is going to fit magically inside of that original shape. Make it transparent so you can see. I can start building this piece by piece using these stations for the wings and for the frames of my hydroplane. So that's the end of the presentation. Hopefully it was what you were looking for.